Good evening, folks, and welcome to the Advent of Code C++ live stream. My name is Craig, and tonight, as we do every night during Advent of Code, we're going to be working through the night's puzzle drop in C++, seeing how far we can get. If you are watching this stream live on Twitch, thanks for tuning in. You can go to the Twitch channel description, and there you'll find links to, one, my YouTube channel, where we have replays of all of these streams, and also the GitHub repo, where we upload all of the code that we write for these puzzle solutions. If, on the other hand, you are watching the stream replay later on YouTube, just check out the video description right down there, and you're going to find links to that Twitch channel with the live streams, and also, once again, the GitHub repo where all of the code lives. So, we are on day 18 of Advent of Code. We're getting into the home stretch where some of the puzzles can get really tricky. We might run into a stumper here. I can't promise that, one of these nights I won't have to take a step back and come back and try and solve the problem later. So far, we've been doing pretty decent, although last night was slowed down a little bit by, trying to solve the problem with calculus in the wrong way instead of just brute forcing it, which would have gotten us the answer faster. But, that's okay. We don't always get there as fast as we like, but we get there. We have just about 3 minutes, a little less than 3 minutes to go until tonight's puzzle unlocks. You can see more and more of this ASCII art picture is unlocking, showing the path of our submarine as we go down in search for the overboard sleigh keys. It's always fun to, get more and more of that that ASCII art showing up as we finish up the puzzles. For tonight's solution, we have, like the skeleton of a program set up here. We have just a main function that does nothing. We've already included the check and IO libraries that I wrote that we use pretty much every night. We have this build file set up in the Bazel build system that tells it how to build this program. And here I've already run it, and it does nothing. It just returns to the environment because the program just returns 0 right now. But we will use this as the canvas for our solution in just a couple of minutes when the puzzle unlocks. Be interesting to see what the theme of tonight's puzzle is. A couple of nights ago we had to write that binary parser here, this day 16 thing for the packet decoder, which was really about just, following instructions very carefully to parse that stream of bits. Last night we tried to solve something that looks like a physics problem, but actually, you can just kind of brute force without actually knowing that much about physics. A couple of nights ago, we had something that was, pathfinding, which we wound up using the A-star algorithm on. So there's a pretty interesting variety in the puzzles that we've had to solve so far, especially over the last few days. I'm interested to see what we'll see tonight. Okay, just about 20 seconds to go here. Okay, let's get into it. Snailfish. Send in the ocean trench and discover some snailfish. They say they saw the sleigh keys. They'll even tell you which direction the keys went if you help one with his math homework. Snailfish numbers aren't like regular numbers. Every snailfish number is a pair, an ordered list of 2 elements, x, y. Each element of a pair can be either written as a regular number or another pair. Okay. To add 2 snailfish numbers, form a pair from the left and right parameters of the addition operator. For example, okay, so adding snailfish numbers means making a pair from the arguments. Snailfish numbers must always be reduced. In the process of adding two snailfish numbers can result in snailfish numbers that need to be reduced. To reduce a number, is repeatedly do the first action on this list that applies to a snailfish number. A number is nested inside 4 pairs. The leftmost such pair explodes. A number is number 10 or greater, the leftmost such regular number splits. I presume it's going to tell us what explode and split mean. During reduction, at most one action applies, for which the process returns to the top of the list of actions. For example, split produces a pair that meets the explode criteria. That pair explodes before other splits occur. Okay. To explode a pair, the pair's left value is added to the first regular number to the left of the exploding pair, if any. Oh, so you got to do like backtracking here. Pair's right value is added to the first regular number to the right of the exploding pair, if any. Exploding pairs will always consist of 2 regular numbers. Then the entire exploding pair is replaced with the regular number 0. Split a right. Okay, to split a regular number, replace it with the pair. The left element of the pair should be the regular number divided by 2 and rounded down. While the right element of the pair should be the regular number divided by 2 and rounded up. For example, 10 becomes 5, 5. 11 becomes 5, 6. 12 becomes 6, 6, and so on. Phew, boy. Okay. Your homework assignment involves adding up a list of snailfish numbers. Your puzzle input. The numbers are each listed on a separate line. Add the first snailfish number and the second, then add that result to the third, and so on, until all the numbers have been used once. Okay. Check whether it's the right answer. Snailfish teacher only checks the magnitude of the final sum. The magnitude of a pair is 3 times the magnitude of its left element plus 2 times the magnitude of its right element. Okay. Okay, this is similar. This reminds me a bit of the binary parsing puzzle in that it seems like it is a structure that can be recursive and some very specific instructions that we have to follow. So let's look at what our input looks like. Okay, bunch of numbers. So let's start by writing a class to represent numbers. So we'll say snailfish number. Are snailfish numbers always written as pairs? Let's see. Say class number. And I think tonight I feel like using subclasses for pairs and for regular numbers. So we will say Although it's like first regular number to the left of the exploding pair, if any pair to the right of the exploding pair. I'm wondering if this is actually going to be usable as a tree structure, or if um, this left and right scanning here is making me think that maybe representing it as a tree isn't going to be the best way to do this. Um, Magnitude. So the magnitude calculation obviously works for a tree. The left, and it's the explode thing where exploding pairs will always consist of two regular numbers, and the entire exploding pair is replaced with the regular number 0. To explode a pair. Sorry, I'm reading these instructions because I'm trying to figure out if we can represent the pairs as trees strictly, or if this left-right requirement is going to prevent that. Pairs left values add to the first regular number to the left. Pairs right values add to the first regular number to the right. And the entire exploding pair is replaced with a single regular number 0. So this exploding pair, there's nothing to the left, nothing is done with the right. There's right value, which is 8. Seems like 8 would be added to that 1, though, right? Okay, so then that becomes 9. And then that becomes 9, I see. And then the pair itself becomes 0. So when we say to the left, or to the right here, I hope that oh, see, this is where things get a little squirrely. So we have this 3-2 pair. This 3 is added to this 7, and then that 2 goes all the way. Like we have to, like keep going up to find a right sibling. Although I think that we can backtrack up the tree and still be able to find that. I hope. Like I'm going to try and I'm still going to try and implement this as a tree. So for private here, in the private section, we are going to keep track of a parent, which is if there is a pair that contains this pair, then then we'll do that. So we can backtrack up the tree and try and find a right sibling. So well, the numbers in this arithmetic are always pairs. So I think I'm going to go ahead and say use a variant between int and a unique pointer containing another number pair to represent left and right. And then so to implement explode for a pair, let's see. You can only explode. Can we only explode a proper pair? Is the question. That like a pair of actual integers, or is it possible to explode something with nested pairs? Exploding pairs will always consist of two regular numbers. Okay. So for this, we will check that both the left and the right hold a regular number. And then we try and find a regular number to the left. So if there is any. So we'll do that. We'll add a private method here that says int star find left const. And it is going to try and traverse the tree and find something that is to the left of this particular number that it tries to find the rightmost regular integer that is to the left of this node in the tree. So it's first going to look at the parent and say, well, so so if the parent is null pointer, then there's nothing that can be done. If the parent's right pointer is to this, then we have to go to the left. Otherwise, we should traverse down. Well, okay. So if I'm going to get sick of using Hold's alternative for these again, so I'm going to use index, even though it's a little dirtier, just because it's going to be. So if I'm going to use the index on the variant, just because it's going to be a little less verbose. So if parent left dot index equals 1 and parent get the 1. So if the left part of the parent is if this is on the left side of the parent, then we have to go further up to find something more left. So we will then return parent find left. Otherwise, we must be on the right side of the parent. So we'll go ahead. I mean, we can double check that here using something similar here, but basically check. Yeah, that better be the case. So if in this case if it's an integer on the left, then we will return a pointer to that integer. On the left. Sorry, parent's left. Otherwise, the node that we've called this from is on the right side of the parent, and the left side is another number. Recursively, sorry if my mic just glitched there, but we're going to recursively go down further on the left side to find left. So then we'll just say return left. We're actually going to want find right. Well, we're going to want the rightmost thing. On the left side, I think is what we're going to want. Well, I think a different thing is going to be if, yeah, so we'll use this rightmost method on the left side. Could be non-const there. Or just double that up. But yes, it's gonna have to be non-const. Otherwise, we recurse down on the right side there. And we're going to need something similar for leftmost, so we'll just go ahead and write that right now. Same deal with left. And we need those trailing underscores. Okay, so going back to our implementation of find left. If there's no parent, then there's nothing to the left. If we find that we are on the left side of the parent, then we need to go further up and in the find left chain. If we find that we are on the right side of the parent, then we need to find, then if the left side is an integer, we return that right away. Otherwise, we return the rightmost on this. So we're going to need something similar on the right for the exploding action. So let's go ahead and do find right. This is going to be very similar. We're just going to reverse the directions of things. So if we find that we are on the right of the parent, then we need to find right further up the tree. If we find that we are on the left of the parent, then if the right side of the parent is just an integer, we will use that directly. Otherwise, we need to find the leftmost leaf on the right side of the parent. So to explode, what we need to do is say we'll say left of pair equals find left. And right of pair equals find right. So for the left side here, we are going to add the left value here. And well, so, actually, if that exists, if that's not null pointer, we will do that. And we're going to do something very similar on the right side. And actually, instead of returning a new number, I've decided not to use a class hierarchy here. It's just going to, return the actual number that should go into the parent. So okay. And then it should be replaced by 0. So to split a regular number, replace it with a pair. The left element of the pair should be the regular number divided by 2 and rounded down. Right element divided by 2 and rounded up. Okay. So we'll just make that, we can make that static, but these are going to be pointers because we're using unique pointers to be able to recursively store numbers and numbers here. So you'll make a new number here. The left is going to equal floor of we're going to do this as doubles to get, floating point result, and then floor will get us back to an integer result, but we'll have to manually cast that back to integer. Oh, the joys of the type system. And then we will use ceiling for the right side. Same deal, and then return num. Okay. So for reduction, so to actually apply a list of reductions now, we've got our explode, we've got our split. To reduce a snailfish number, you must repeatedly do the first action. After which during reduction, at most one action applies. Then you start again. So I think we'll see here. So this Boolean method reduce will return true if anything actually changed in this reduce pass. So we'll keep on reducing until reduction no longer applies. So if any pair is nested inside okay. So we have to do all the explodes before we do any splits. So, okay. Oh, and this num obviously has to have. Oh man. Okay. So instead of making this static, I'm actually going to make this a member function because because when we create a new pair, it needs to know what its parent is. So yeah, that's important. We'll probably make explode and split private at some point, but we'll see. Pairs nested inside 4 pairs. Okay. Should we call this bool? Well, call it maybe explode. That depth is the recursion depth. Make that an optional, because this might not explode. Otherwise, we will keep on recursing. No, that's not actually how I want. Sorry. I know I keep changing my mind on some of this, but I just want to return true if it explodes. So if depth equals 4, then if depth okay, so if we're at depth of 4, then I think you know, we need to explode children here. So oof. Yeah, I know. It doesn't sound great. If depth is 4, then if the left is a pair, then we need to replace the left by the result of exploding the left. Otherwise, if the right is a pair, we would do the same thing. Otherwise, we recurse further. So say if left is also a pair and we may be exploded on left, depth +1, we will return true. And similarly on the right side, otherwise, nothing left that can possibly explode here. So you return false. Okay. So to reduce a big number, we first try to maybe explode anything in it. Starting at 0 for the number itself. I think we'll test this out. So if we exploded anything, then something happened on that reduced step. Otherwise, we need to try for splits. So we need to just try and find Yeah. So for maybe split, just if left dot index is 0 and the value held there is greater than or equal to 10, then left equals split on that value. And we return true. We have that, and we descend down the right hand. Oh, we should always be descending down the left-hand side first, I think. Yeah. Yeah. So otherwise, if left dot index is 1 and we split on the left, we will continue recursing down there. Okay. And then we do the same thing on the right side. So if right is a number that is greater than or equal to 10, we will just split it right away. Otherwise, we'll continue descending down on the right. But if we did nothing, well, we did nothing, didn't we? So if maybe split, return true, else return false. Okay. Actually, I think we can make this into a loop that just does the whole thing, so we'll just say if maybe explode, we will continue. If maybe split, we will continue to the next iteration of the loop. Otherwise, if we did neither of these things, we will return. That should give us our full reduction. Then explode and split, I think, I'm actually going to change these and make these private methods because we don't need to see anything about these. So let's see. Now, how is magnitude calculated again? Magnitude of a pair is 3 times the magnitude of its left element plus 2 times the magnitude of its right element. Regular magnitude of a regular number is just that number. Okay. So, if the left is a regular integer, then mag plus equals 3 times that regular integer. Otherwise, mag is going to be 3 times the magnitude recursively calculated on the left side. And we'll do a very similar thing for the right side, except that it's just 2 times the right side. Turn the magnitude. And now the thing that we actually have to do is parse this as well. So let's write a constructor that, or a factory method that parses this. So we'll do, since we want everything to be unique pointers here. Okay, so the front of the representation should be an open bracket. Then I may actually want to use iterators here so that we can just make... Oh man, I don't know how I want to do this actually. This is actually going to be a slightly complicated parsing situation. So this depth is going to represent how many brackets deep we are in scanning. And so we'll go through characters in here and say if well, we'll actually do this with a switch statement, I think. So I'll switch on the character. So in case it is an open bracket, depth increases. In case it is a closed bracket, depth decreases. In case it is a comma, only if the depth is 1, meaning only the comma is only enclosed by the outermost brackets for this number that we're trying to parse, will we actually care about this particular comma. Um, if depth is 1, then you'll say the comma is at that position. For now, we will not care about the rest of the characters. So at this point, depth should be back to 0, and comma should not be the -1 that we initially set it to. So we should be able to split by the position of this comma to find to have strings for each side. So we'll say left rep equals rep dot substring from 0 up to the position of that comma, and the right rep will be the substring from the position of from 1 past the position of the comma, or actually no, it will be from 1, and then we'll do comma -1 because we don't want the opening bracket from the outside here. And similarly, right rep will be the position from comma +1 rep dot size minus comma. Well, to make this a little easier on myself, I'm going to pop back or remove suffix of 1 there. So if we can successfully parse the left side as an integer, we'll try and do this here. If we can successfully parse that, then we'll do that. Otherwise, we have to recursively parse it. So we'll say actually, I'm going to include parent here, because that's going to make it a little easier to track this. Okay. And not this, but the num that we are working on will be its parent. And we will do the same thing for the right side here. And then finally, we will return our whole parsed number here. Now, we theoretically have everything that we need to, well, no, we need to be able to do addition. So let's see here. Add the first alphabet number sec. Okay. Yes, we need to do addition as well here. So Um, we form a pair with the left and right parameters. So we'll write just a static add method here. Okay. We need to set the parents properly. And then we will put them into num. Okay. Now, we can actually write our main program, our main function here, to get everything here. So first thing we'll do is read lines using our pre-written read lines from file routine. Then we'll parse the first one, and then we'll go on from there. So we'll say for a line iterator ranging from one past the beginning of lines to the end of lines, we will do this. We'll have we'll parse that line, and then we will do the add between our running result and that next one, and we will need to move both of those. And after every addition, we should reduce it. And then finally, we should print out the magnitude of the result. Okay. Theoretically, this is a solution. However, I have almost certainly made some mistakes in here, so we will probably get into some debugging, but we shall see. We need dependencies on the abcell strings library here. So let's try and build and run this program on our day 18 input. double dash there. Sorry. Okay, it says 13,329. If this is correct, I will be very impressed with myself. I kind of doubt that it will be, but we'll see. Okay, not the right answer. That's fine. So for some debugging, I think one important thing to be able to do is to actually print out one of these numbers. So we'll just do the make a little print method here. So we'll say call it debug print, I guess. We could actually make a stream insertion operator, but I'm just being a little bit lazy and just making this a method that prints out things. So we'll say if f.index is 0, then we will print out what is actually held there. Otherwise, we will have the left side do its own debug print there. We'll then put in a comma. We will do this same stuff for the right side. And we will put in the final closing brace there. So, let's grab some test data from the website just to see how this works. So, let's just look, for example, at this explode thing. So, and we'll put in, well, let's just see if it parses the first one correctly. That'll be a good initial test, I guess. And then cat, we'll do head on our not day 15, day 18. Different big numbers there. So we have 4, 3, 3, 4. So the parse appears correct. That's good. Let's put in something that would have to be exploded and see if that works properly. Oh, sorry, I'm not showing you what's going on over here, but the parse went correctly. So that explode, okay, explode, the reduce that would explode does not work properly. So am I off by 1 on the maybe explode here? Let's try that again. This is 0, 9, 2, 3, 4. Okay. So was it just an off by 1 on the maybe explode is the question. Let's go ahead and run it again on the actual input and see what it gives us, and, you know, see if we've at least found another problem. So 3699 is the magnitude now. Let's give that a try. All right, we got it. And 485, I guess, you know, people are slowed down by this, so we're doing all right. Second question on the back of the homework assignment. What is the largest magnitude you can get from adding only 2 of the numbers? Notice that Snailfish addition is not commutative. That is, x plus y and y plus x can produce different results. Okay, this this is actually pretty easy now that we've done everything that we've done from part one. So we just need to. Oh, I realize that add though um, is it's a little frustrating. I mean, we could just reparse this, but the way that we have written add is it's destructive in its arguments. So we would have to reparse everything, which is not the worst thing. Um, yeah, I so first thing I'm going to do here is just take this day 18 part 1 and well, very first thing I'm going to do is I'm just going to commit make a commit day 18 part 1 solution here, and then we'll copy this to start working on part 2. So addition is not commutative, so we need to try both possible ways here, but I think this is not going to be the worst thing in the world. But it has to be two different numbers. Can't be the same number added to itself. I did notice that. So let's get into part 2 here, and we'll just copy and paste. I don't think we're going to need any additional libraries for this, but we'll have our part 2 here. And so the way that we'll do this is just we'll keep all these lines and we will reparse, because that's going to be the fastest way for me as a human to do this, not necessarily the fastest for the computer, but we'll just reparse every time we're trying a new pair of lines. But we'll say int max magnitude. We'll start that as 0, and then for we're going to use iterators here because that will allow us to distinguish. We'll be able to compare iterators and make sure that we're not using the same number twice. We're not adding it to itself because it did say two different numbers in the snailfish homework. It not equal lines dot end plus plus outer it. We are going to have a very similar thing for inner. If they are the same, then we are going to continue. We're going to skip over that pair because they do have to be different. So now we will say we'll parse the outer and the inner. I'm using auto very liberally here, more so than I would if I were being really serious about this, but I'm just trying to move fast right now because we have most of what we need for the solution to this problem. So we've got our result from adding there, and then we're going to update max magnitude as the maximum of the running magnitude and the magnitude of that result. Although I realize now, of course, we need to reduce that first. And then we need to try again for inner first, because snailfish addition is not commutative. So outer we will reparse, inner we will reparse. Result, we are just changing the order of inner and outer here. And we will reduce, get the max magnitude there, and we will print out the max magnitude now. So the biggest magnitude that we can get from adding any two different snailfish numbers in the list. Let's go ahead and run that. 4735. Let's plug that in and see if that is correct. All right. So as I suspected, we had most of what we needed. 485 and 490. So we were close to the best that we've done this year, really. Definitely the best that we've done on part 1. Part 2 is pretty simple if you've already done part 1, as you saw. But even though this took a relatively long time, by the looks of the leaderboard, it took a lot of people a long time to implement this. So it is, about playing with this, kind of funky tree structure of numbers. And I think that the potentially difficult thing about this really is explode, being that you need to backtrack up, that if you structure it as a tree, like it says, the first number to the left or the first number to the right. So you need to be able to backtrack up the tree and then navigate down to siblings in a way that will land you to the first one to your left or the first one to your right. So navigating the tree, I think, is probably the trickiest part of this. Using a variant to represent left and right, like I wound up in a lot of places in here. If you look at the code, I'm using standard get 1 or like looking at the index on things. That is kind of ugly. It is not super readable. It was fast to write, slow to read, perhaps. I may go back and clean that up so that it doesn't look quite so messy. But nevertheless, although this was a kind of challenging puzzle, this was a puzzle that took a while, I think that things went pretty well. Didn't get distracted on too many garden paths. I think the only thing that ever went wrong, really, was I was just off by 1 on that calculation of how deep we needed to be for maybe explode, which is why having that debug string was good. But overall, yeah, I'm very happy with how we did tonight. I hope that you've enjoyed the stream. If you are watching on Twitch, remember you can go to the channel profile, and there you will find links to my YouTube channel where we have replays of all of these streams, and also to the GitHub repo where we upload all the code that we write. If, on the other hand, you're watching the YouTube replay, just check the video description right down there. You're going to find links to the Twitch channel for the live streams, and once again, a link to that GitHub repo where all of the code lives. Thank you again for watching, everyone. We are getting into the home stretch of some really difficult and interesting puzzles. I hope you had fun tonight, and I hope to see you again tomorrow. Bye-bye.